are going to discuss about differential calculus and its applications in real-life situations. In this video, we'll be discussing about differential calculus, but what is this subject really all about? Well, before we start, we'll be defining first about differential calculus. The word calculus in Latin means small stones or pebbles because it is like understanding something by looking at the smaller pieces. Fun fact, did you know that the term calculus is short for calculus of the infinitesimal? It is because we analyze very little things in math for us to help understand the bigger picture better. And by bigger picture, I mean the whole problem that we'll be solving later on. Then the word differential means infinitesimal changes in a variable relative to another variable. Well, it means that we're in the process of finding a derivative of a function at a chosen value, describing the rate of change of function near to the chosen value. This process is called differentiation. The derivatives are the heart of differential calculus. Thus, when you combine these two words, differential calculus is defined as an instantaneous rate of change of quantities in derivatives.
Students that are applied in this course may wonder why differential calculus is included in the list of requirements. Actually, there are many applications where these derivatives can actually be used and is applied. For students who have science-based course and engineer-based course, they need to study derivatives for them to be able to apply this in the real life. Same thing to engineer-based students, they can use derivatives to measure a machine rotating per minute, how much water is added to the cement mixture, how much an engineering company has earned per year, how long the truck is delivering a material at a certain speed, and the list goes on. The skills a student needs to be able to fully understand, identify, and answer all the derivative problems is to make sure that the student understands all the derivative principles as this will be applied to problems in real-life scenarios. Analyze the problem carefully and find out what is the missing variable or item in the problem. Then use a derivative rule that can easily be used and do it step by step to be able to get the correct answer. And now, we will show you a sample problem and will teach you how to solve the derivative problem in the process. Have our given t equals 0 in the beginning of 1900s. We have to know the time in the beginning of 2000s. So we have to subtract 2000 into 1900s and the answer is 100. So now we have to evaluate f of 100. So 46.9 quantity 1 plus 1.09 times 100 raised to 0.1. So it will be 46.9 times 110 raised to 0.1. The answer will be 75.04 or approximately 75 years.
For the second part, the rate of change of life expectancy of a male at the beginning of 2000 is being asked. Therefore, we have to differentiate or get the first derivative of the equation with respect to time. From the given equation, we will find the first derivative of the said equation using the power rule. So after simplifying the equation, the first derivative will be 5.1121 times 1 plus 1.09t raised to negative 0.9. So we will use the value t equals 100 in the beginning of 2000 and the answer will be 0.07436. We can now conclude that the time a male beginning at 2000 could live 75 years and the rate of change of life expectancy of male at the beginning of 2000 is 0.074. This is the end of the tutorial.
We hope that you learned something from us.
Again, I'm Ian Rosaria.
And I'm Angelica Salet.
Thank you for listening.